Let's look at a simple compose application. When you're creating a compose application, you begin by selecting empty activity on the new project wizard. Everything else is pretty much the same. And when this project fills, you'll notice a few similarities and a few differences between the artifacts that get generated for us between a compose app versus an application that uses um, older view system. So while this builds, we can simply walk through here. So first thing to always keep in mind is that compose is a declarative UI framework. What that means is it takes a functional approach to building your user interface, which is a series of functions that call other functions. These functions are called composables, and a composable's job is to emit UI elements to the screen. That's what gets drawn in our activities or wherever we're viewing the user interface. And there are certain constraints placed on these functions. Again, because they're functional, they are based, or their operations are based almost entirely on the information that is passed to them, and they should be what is called idempotent, which is to say, if I execute a function once with a certain set of arguments, and then execute that function again with the same arguments, I should get the exact same result. Additionally, the function should not cause any side effects if well written. That basically means whatever the function does is limited to the function itself. It does not manipulate state, though we're going to talk a little bit about that in a moment. And it should not essentially modify anything outside of the context of the function that would impact some other aspect of the program. So that's the general idea here. And again, the whole compose framework is just based on functions. So we start with the stuff that we know before, but now we get to set content, where before this would take a reference to a layout or take an object reference that would be used as the UI for the activity. Here we see that this one takes a function that is a composable. This in turn takes another function and another function, another function. And these functions are all generated for us. So in fact, if we just go into our list of generated artifacts here on by theme package, we can see a simple compose app theme is here, generated for us. Material theme is generated. Have some versions of this. Other composables that gives us things like themes, etc. But they're all composable functions. We know they're composable functions because of this composable annotation. And in our activity, we see that it basically goes all the way down until we get to greeting, which is our composable function, meaning it's generated for us, but this is where we start to write our own code. And these can all be modified. So as the name suggests here, this function is going to not a greeting. It right now just takes a greeting. We'll talk about this in a second, but what I want to do here is create an application that mimics a basic form. So I'm just going to refactor this. I'll call it user form for simplicity. So user form takes these two arguments. It takes a name, it takes a string rather, and a modifier, where the modifier is given a default value. A modifier in Compose, so modifier is a Kotlin class that is able to give attributes that it impacts the look and feel and the behavior of the composables to which they are applied. So a modifier given to this text composable. So again, we're all just calling composables all the way down. We'll really get to the lower level composables in a second. I'm passing a modifier will allow this text to, we'll be able to specify things like how much padding should this text composable have? How much space should it take up? Different properties, and then we can also specify some behavior for different composables, again, using the modifier. And there are different constraints like which attributes can be applied to which composables, like certain composables that, let's just say you want to fill up a certain space. Well, that only works if you are inside of a larger composable container, things like that. So you can think of this as the set of attributes that are applicable or that will be applied to a composable if we want to give an analog to the view system. So we have this text composable that is going to be drawn to the screen. So this will be emitted. A text, this is one of the lower level composables for pretty much, but not all of the views, the basic views that exist in the view system. You can find an analog in the compose framework. So you'll have a text composable. Instead of edit texts in the view system where you type in your text values, you have a text field and different variations of that in compose. Again, we have different analogs. We have buttons, we have images, things like that. And at the end of the day, your composable function's job is simply to specify what the UI will look like by utilizing other composables. And that's pretty much all of the aspect of application that deals with the visible portion, right? When we say that the UI or the views would draw themselves and then respond to events, here the composables emit UI elements. That's basically the drawing responsibility. And later on, we're going to see the respond to events bit. In fact, we'll see that in very quickly. And then later on, we'll look at issues relating to state management. There are some interesting concepts that we need to be mindful of, that we need to consider as we build our application. Okay, now I have here this generated text composable that's inside my user form composable. So you can think of this right now as my main screen. But the one thing that we're missing here that was present in a view application is a preview, right? Usually I'm able to see the layout file using a WYSIWYG editor. What you see is what you get, so I can drag things around. And I always see or have a general notion of what my application's user interface is going to look like. Well, because everything in Compose is done in code, albeit functional code, we don't have a layout. If I expand my press folder, I don't see a layout folder here. That does not mean, however, that we cannot see what our user interface will look like, because there is this separate composable that we're able to create where we add this separate annotation called preview. And what this will do is use this function, the function that is specified as preview, the composable that is specified as preview, and execute it, render it in a preview window for us. So I can see that preview window by simply going here to the top right and selecting tab. And initially it's going to tell me I need to build my application. And that just usually means just clicking this link. And sometimes it works. Most times it works right out of the bat. Sometimes it doesn't. It might break. If anyone has used Android Studio more than twice, you know that it has bugs. But if it doesn't work, then we'll just get it to refresh by changing some aspect. Okay, it looks like we're getting somewhere. Nope, it broke. So what we'll do here, or what I'll do here, is just modify some aspect of this, of my composables. And this will give me, what this will do is automatically refresh the preview, or in theory it should. And usually that refresh is what allows me to see pop-up. Be nice again. It would be nice to just have this work. Okay, so I made a slight change there. Still having a render problem. Oh, there we go. Yeah, so again, this is not going to be news to anybody who has done anything in Android. Just sometimes they don't work, and you just need to prod it to try again. So this is the preview window that is generated from here. So the preview is basically, again, invoking user form. where user form, and this is encapsulated in a theme, and user form is passed the string demo. And that string is used as the or is used in the argument to initialize the text parameter for our text property and our text composable. And if I just hover over the text composable or check the documentation, that's the proper way to do it, I can see that there are a ton of parameters that are defined. Each one has a default value except text. So all I need to do is specify text. If I leave any other property unspecified, it's fine as long as text has a value. So this gives us the text. Now, as the name suggests, what I'm trying to build here is a form. So I could use a text and make that a part of it, but I'm going to get rid of this. And instead, I'm going to go straight to a field to capture user input. So let us say that I want to capture just a couple of items, name, email, whatever. I would start with a text field. And this text field, again, if I hover or check the documentation, okay, if I import and then hover or check the documentation, I'll see that it takes a set of properties. Keep using the word properties. It has some parameters defined, or it takes a set of arguments to then manipulate its own properties. Now, the ones for a text field that I'm really concerned with are the value, which I will simply initialize to a blank, an empty string for now. I'll come back to this later, and we'll see how we actually work with the value. There is a label, and our label takes a lambda that returns a composable. So this, for example, I could make a text. Sorry, I said it returns a composable. It doesn't. It emits a composable. So it's UI elements. So this text, and then I can just use the default, and I'll say enter your name. And the last thing this text field needs is a value for the on value change parameter, and this takes a lambda. Now we're going to come back to this lambda and fill it out in a second, but let's just give this a moment for our preview to generate, and zoom out because we need to be really zoomed in. So this is the preview of my text field. It has no value. The label is what gets displayed here, and when I do, in fact, run this application, let me probably need a. Oh, I have no target devices. That's not fun. Let's see what that's about. Let me pause here and fix that real quick. All right, I went through quite a few different changes and modifications, and it turns out I had loading devices here because I had an old physical device plugged in that was, I guess, preventing ADB from completing its enumeration. So, hey, bugs, what can I say? And I went through a whole series of updates trying to find what the problem was. Anyway, continuing. So, trying to remember where I was to continue, but we've implemented this field, text field. We can see this in our preview. We now need to be rebuilt. A whole bunch of presets here. And ultimately, once we get this application up and running, we'll be able to see that I can enter information here. We'll see that label will disappear. And if I attempt to not disappear, rather, but shift out of the way, and then with a nice little animation, allowing me to enter my info. Application a little time to. Right, our nation. And we can see here, first we're right at the edge. We'll deal with that in a little while. Highlight the box. See this name shifts away. And you'd think I could type my name, but nothing is actually happening. I'm hitting the keyboard and I'm not seeing anything here. And this has to do with the functional nature of compose, which is when I specify that this is what my text field looks like, and it has a value of a blank empty string, then that is exactly what my text field will look like. Always. It will always have a value of empty string. If I want this specific view to be updated with text as it's typed, I need to explicitly change the value property here because compose runs by composables emitting their current UI elements. They do not facilitate state change that happens as a part of the composable function itself. And that is just how functional programming operates. You do not change state. So if this has a value when this compose function is composed, then that's the value we will see. Now, compose has this feature called recomposition. This is an automatically triggered action where Android/compose will sense when a certain change in the state of the application requires that a compose function be recomposed, that is, redrawn or re-executed. And what triggers this recompose is when a value that this compose is dependent on, this composable is dependent on, is updated, it's changed. So if we want a text field to show changes or to show the text that is being entered, what we need to do is to tie this composable to a field that can then be used to trigger a recompose, where every time that recomposition happens, we have a new value that will be drawn. So what was a very or relatively simple or straightforward process when we were using the view system becomes a multi-step process when we are operating on a composable. Now, it's not the worst thing in the world, and it does become habit, and it actually gives us a lot of power and capabilities later on. But let's just go through the process now for the first time and get an appreciation of how it sort of comes together. So, generally speaking, if a text field needs to be changed, the value needs to be dynamic. For that to happen, we're going to need a few things. We're going to need a property outside of the text field itself that will store the value. That can be defined in much the same way we would have defined a property in a normal Android application. So we might name this something like name, but instead of just saying name, we're going to do something necessary here, which is we are going to delegate the setter and getter of our name property to a function called remember. And what remember is going to do is allow for the value, the current value or the last value stored in name to be retained whenever this function is recomposed. That is to say, if we were not using the remember and we just said name is equal to some string, then every time the composable is recomposed, it would reset to this value, which we would then not be able to do anything, not see the change reflected. So we use by remember to allow for information to be retained across recompositions. Now, once we have that, we can simply say we're going to make what we want to remember is a mutable state of, and then specify the type. For us, it's a string, I can just put an empty string. We should have had an import happen automatically, or it would have been nice. It didn't. So I'm going to go to remember, hit Alt Enter, and I'm going to import the set value. And when I do that, the by is the error. So there are set values. A set value needed to be imported. A get value was automatically imported. The set value wasn't. It would have been nice if they were both imported, but I needed to do it manually. So now I have this property. And what I'm going to do here is I'm going to say the value for this text field will reference name. But this is not sufficient. If this was the only thing I did, then I would not actually see an appreciable change in the application's function. Typing anything here, I'm hitting the keyboard, I'm not seeing a change. What I need to do is update name. So we're saying, yeah, the value will come from name, but where does name get its value? Well, we're going to say that name gets its value here in the onValue change. Every time the user hits the keyboard, the current value, which includes the value of the last key press, is passed to this. It will be invoked, will be passed to this lambda with it representing the current value of the change. So for us, we would simply say name is equal to it. So it is what was just typed, or the value that occurred after the user hit the last key, and we're going to set that to name. That change is going to trigger a recomposition, which will then have the text view be redrawn, and it will take the new name value. So running this new updated project, we see that now I'm able to type what's your name. Would have been nice if it type. Should say Carl. Uses to be linked to this emulator. Just a few more problems, just a few more bugs. So again, it's working here. My keyboard isn't working, but I just want to demonstrate that everything we just did was in fact necessary. Had I not made this change, and then I ran the application using the on-screen keyboard, we can show that the effect would not have been visible. Now I select keyboard. If I have to bring this keyboard out every time, this is going to be a little tiresome. But as you can see, we're not seeing the change. So this piece is necessary. So this is the text field. So that's for name. If I now want to have another field, let us say simple. If I want to have another field for email, then I would sort of repeat this whole process. First, I need a property to remember email. Create a copy of this. Email. Is the same value here. It's email. Then the unchange is email. I will reserve judgment as to whether this is easier or harder than the view system. This is just how it works. Now, whether from the preview or if we ran the app and seeing it executed on the physical device, you're going to notice something. We have two text fields, but we're not seeing both of them. That is because one is superimposed over the other. When you specify composables in this manner, they're simply just stacked on top of each other or in the same physical space in compose. In order to address this, we would need to put these composables inside of a container, of which there are a few to choose from depending on the effect that you would like. And you can think of this in a way as not being dissimilar from the layouts that we would have in the view system. So in the scenario I have here where I would like to have one assumes a text field above and another below, what I can do is I can place these composables in a column composable, where the body of the column will contain the fields. When this generates, you will now see that I have the fields in a column top to bottom. I also have, as you might imagine, a row that will give me left to right, and thereafter different variations of this or different types of containers that will give me different effects. So a column right now is being used to fill this in, and if I were to run this app, again we see well, not again, but now we see that we have them stacked. But let us say that I wanted to modify this so it looks a little nicer. For example, right now, they're in the top left of the screen, which may not be what I'm looking for. Maybe at the very least I'd like it centered, but also perhaps just not right at the top. So there are different things I can do here depending on the effect I ultimately want. Maybe I want it centered. That might be straightforward. But let's look at how we can do this. So the first thing I'm going to do is I'm going to give my column some information that I'll pass in as an argument because this is just another composable. It's a function that I'm invoking, and I'll see that this column composable takes a set of arguments. It takes a modifier or a set of parameters. It takes a modifier, which we can use to give it certain information. And it has a vertical arrangement and a horizontal alignment parameter that we can use to specify other things. So I could, for instance, say that I want the, let's get the name again. So I want the vertical arrangement. So vertical is top to bottom. I don't really have anything I want to do there. There's not immediately. But horizontal, I think maybe horizontal arrangement. I think I would want to perhaps horizontal alignment. I center it. So let us say I have a horizontal alignment. Well, I want to center the text field. So that keep that in mind. That's my goal here. So if I were to try to apply something like the horizontal alignment to the column, let's see what we would get. So the different properties it can get are specified in the horizontal alignment. It's in the alignment class. So bringing up the alignment, I can do end, start, or center horizontally. So if I were to center horizontally, see what we get here. Do we get what we expect? Run this application. It says no. Still here. Now, this we could try to address by recognizing that even though we've specified that it should be centered horizontally, by default, the column composable is not really taking up more space than it needs. It's more or less wrapped around the views and therefore the composables, and therefore it, even though it is centered horizontally, there's nothing to center in. If we want this to be centered, what we need to do is give it a modifier where we can tell it to take up more space. So here I can specify that the modifier parameter, let's just get some room here. The modifier parameter, and there are different ways I can do this. I can take the modifier that was passed into me, and I could something like fill max width, which now tells it to spread itself. And even though the preview adjusts accordingly as well, so that's good. Thought it would update, but now we see that we get that effect. So it's filling maxed width, so it's going as wide as it can, filling up the space. And now when we tell it center, the content is centered. We could do something similar with vertical, what is called arrangement versus alignment. So let's break this across different lines so it's cleaner. And what I actually want here is vertical arrangement to be, now I get the proper values can be found in the arrangement class. In this case, it's just center. If I look at what the result of this change is, I will see that while we still have the centered horizontally, we're not getting any vertical centering. And you can imagine why, because in the same way the column was wrapped around on the horizontal around the view, the composables. You're gonna have to excuse me if I say views every now and again. But I'm always referring to composables unless I'm explicitly making a comparison. We also need to. It also wraps on the vertical, and therefore we need to extend the vertical, which we can do by simply, instead of saying fill max width, we can just say fill max size, and that's width and height. So we don't have to do them independently. We can just have both happen at the same time. If we only wanted one, we would call one. If we want both, we call both. The result. All right. The last thing we might want to add, well, for now, is a button. So let's just say there's a button that we wanted to be able to click to have the users to trigger some action. Then we can add another composable. Might be able to guess the name, button. But the term button is so universal as to not really have all that many versions, variations. So our button took long enough. So the button takes an interesting form. So when we take a look at how our button works, we see that it takes a set of parameters: on click, modifier, enabled, shape, etc., etc. And so you can imagine that something like what should happen when the button is clicked is provided by simply saying on click, which will take a lambda, and we can then have our imperative code here. But you'll notice that even though the button, okay, now that it's drawn, we see that there's nothing here. Whatever you want to have the button display is what is placed here. So in this lambda, so if we wanted this button to show text value, it's an image or something else, we would say you want text possible, and you have the text value save. Once that is done, we see our button. So let's do something relatively simple here. And we'll just, whenever the user enters their information, we click save. We want to pretend like we're doing something in the background, but all we're going to do is pop up a little message that lets the user know that they in fact clicked this. And maybe we could use something else here by maybe adding some padding. How about we add padding to this button? It's a little better spaced. Again, you can always check, is there a parameter that does a particular thing that we want? If you don't find it in the list, then it is probably the modifier that would need to be specified in order to the behavior that we want. So fire at the top. So I can say that the modifier is equal to, again, I have a modifier that was passed into me. And I can say here, padding 8. What I want is density independent pixels. So I need to specify that this 8E. And I'm going to do an import, giving ADP, put comma, because argument that being specified. And now we see that the button is spaced a little. I want it to get ridiculous. Just for the sake of specifying that we want padding of 28, as you see, spaces according to 16. So I can put that, I can give my button that padding. I could just as easily have given the text, the text field, the email text field, a bottom padding, which I'm able to do. So padding here is padding all around, left, top, right, and bottom, but I can specify padding independently if I need to. So here is in our onClick what we want, and this is where we can write just raw Kotlin code, which allows us to do a lot of things, including, as you saw here, we're able to actually, in a sense, quote unquote, modify state in the way that we might think of it. But because it's been specified in this lambda, in this callback, versus as an attribute in, or a value in the field itself, in the composable itself, the composable is still sort of meeting the criteria of being functional, which is to say the behavior is not a part of the function. The behavior is just a value being passed in. And then internally, this is executed for the application to respond to whatever event that lambda is meant to handle. So continuing here, or the same idea here, when we click, we just need to specify what code should be executed. This is our callback. This is how our composable, in this scenario, responds to events. So if I wanted to pop up a toast, I can just use a toast as I would before. And a toast takes a set of arguments. It needs context, it needs a char sequence, and it needs a duration. Two of these we can get relatively. In the past, to get a context reference, we would simply say this or this at, and that would give us some reference to context. But in Compose, it doesn't actually work this way. In Compose, in order to get context, we need to reference a specific object. That object is called local context. Now, I'll start typing it here, but I'll show you that when I access it here, local context, it's going to tell me something. So local context dot current is how I get a reference to the currently accessible context object. But as I type this reference inside of my lambda, I get an error. It's telling me I can only access this value within the concept within the context of a composable. So the message is basically telling me I have to access this in a composable function. Right now, where I'm typing it, I'm not in a composable function. I'm in this lambda. I'm in this callback that I'm defining. So whenever we want to access context, we actually need to make a reference to this context object outside of the lambda where we actually want it, and firmly inside the composable. So for me, it can be as simple as saying context is equal to local context dot current. From here, then I am simply able to take this context object back to my make text and reference it, and then give all my other references the text, we've saved your information, whatever, and the time, how long it should be shown. So post dot length short, and then I want to show my toast object. I run this code, version 1, click save, toast. If I wanted to personalize this message, we've saved your information. Thanks, name, saved your information. So we can reference my remembered value here. bug there. And that was clicking it. Thanks, nothing. That's fine. I didn't type my name. Keyboard doesn't work, so I should try handwriting, but I won't. Carl. Should be an easier way to do this. The keyboard. Save. Carl, saved your information. So that's how I would do something like this. Now, before we go further, let's talk quickly about what this was, because this is a lot of hand waving. Like, we know what context is, but why did I need this specific reference, and what does it do? So take note of something in Compose, and it is that when there's information that we want to access within a composable, it's generally passed into us. So modifier is passed into our scaffold. It becomes available to us, or it's passed into user form. It becomes available to us here that we can use, and I can even pass that same modifier into another composable. So it keeps getting passed down the chain, or passed down the tree, I guess, where one composable calls another composable. Now, if it is the case that an object is going to be passed into a chain or a tree of composables that goes however deep, 5 calls deep, 10 calls deep, however it is, you may make a determination that having to accommodate that information being passed down by modifying the signature of your composable, the arguments that it will accept. We're actually done with name here. I need to come here and from user forms, no longer calling it with name, and also remove preview. We're no longer using that value. Anyway, so instead of having to modify all of the signatures, which you may choose to do, that is certainly the way that you would. That's what's generated for us. You may decide that you would like to be able to access that without having to modify too many. When you pass a value via the list of parameters, or as an argument to a composable, you are explicitly passing that value. Again, that can be fine in some instances, but you have another option if you would like to make that information available, and it is using something called composition local, or locally scoping a value or an object that becomes available further down the compose tree. In this way, you are implicitly passing values that can then be accessed further down the chain by some other composable. So local context is a composition local that is available to me that defines the context object that I can then use at different levels in my composable. So it's accessible to me. There are other versions of composition local objects that you can access for different useful things, and you can also create your own. So you have these two options. You can explicitly pass elements down your call chain, or can define a composition local. And again, as is the case here, some of them are defined for us. You can use a composition local to implicitly have access to that data further down the chain. And then, as mentioned, when it's defined like this, it can only be used inside of a composable directly, whereas when we were here, we were inside the lambda, not explicitly inside the composable, so I did not have direct access. I had to extract it as a value, a regular value, and use it here. Okay, so a couple more things that we want to cover here. First is an interesting feature, and I'm sure there's a clear motivation somewhere as to why this is. But even though we have our mechanism here of defining a way to make sure that information is retained um, as it's typed, specifically to make sure information is retained as the function is recomposed, it turns out that this information is not retained if my application goes through a configuration change. So in the case where I type my name, Carl, if I do a device rotation, which would cause my activity to be restarted, the information is lost. This is, again, by design. It is not entirely clear to me why we have this, let's call it a feature. Now, if you would like to retain information across configuration changes, and we're familiar with this to some degree from the view system when you want to save your state data, views tend to retain their data automatically. That is not the case in Compose. If you want to retain that data, then instead of using remember, you would use remember savable. That's it. That's the only change. So much so it's straightforward enough that I would say to you, always use remember savable unless you have an explicit reason why you would not want a value to be retained across a configuration change. And I certainly don't have one in 99% of the scenarios I can imagine. So here I've typed my information just to hide the key. And now if I do a device rotation, or information being here. So again, using remember savable is preferred in most cases to remember, because remember by itself will not retain information across a configuration change that forces an activity start. Now, as I mentioned earlier, there's pretty much an analog in Compose for all the view items you are likely to use in the view system, with one glaring exception, and that is the spinner. The spinner in Android has not been replicated in Compose, and you are instead expected to sort of mimic or move past, in some respects, the capabilities of the spinner by using or composing, pun intended, the functionality using composables. So there is no spinner anymore. And I will leave you to find, there are tons of tutorials as to how to build them. They're sort of a lot more, a lot more complex than any of these we have here. So I don't want to make this video any more cumbersome than it needs to be. But you can find some copy and paste examples out there that would give you a spinner. I just wanted to show you one other thing that is, again, not perfectly replicated, but is sort of achieved through leveraging features in the Compose framework. And that is what we would consider a list, which would be achieved using the recycler view traditionally. We are no longer able to use a recycler view. However, there is an interesting capability, if you will, or one of the interesting bits of using Compose is how we're able to achieve similar functionality, but now we're able to achieve it by leveraging the capabilities of the language itself. Now, let us say that I just wanted to have a list of elements. So that list might be a collection of strings. Simple. I get colors that supports, but we're not even going to change the color, so it doesn't matter. And finally, if it is that I wanted this list to be shown in in a collection as they would in, say, a recycler view, then the compose way is to go through each of the elements one by one and create a a set of composables that gives you the behavior that you want or the look that you want. So a list of colors that I wanted to say just drop below this particular element, I could do that by creating a column or a lazy column, which is closer to recycler view, that it only instantiates elements when they are visible or when they're about to be visible, but replicate that feature as well. But I could have a column where I could, similarly as above, I could center things, but in this case, what they will be centered in the general collection, but the left side of each of my elements will be aligned. That's the behavior I want here. So what I'll do here is basically take each of those values and loop through them. And when I loop through them, I can then take the color and create a text composable. That gives me the list. From there, I could give each of these a modifier to make them clickable and do different behaviors for each one. But you start to see how in some ways things can be a little more cumbersome, like a text field. But in other ways, things can be simpler, like getting a list, because now we're using the language features to get the behavior that we want, to get the look and feel that we want, rather than relying on a separate paradigm of defining elements inside of an XML file that then gets inflated and shown inside of our activity. Here, we're just writing functions that are calling other functions to give us the behavior that we want. So this is a simple and bare bones introduction to some of the features available to us in Compose. There is tons and tons more to learn, as you can imagine. And this is the new way that we're going to build applications, or at least the user interface of applications in Android. We're moving away or have moved away from the view system where you will only find that now in legacy code. And it's relatively straightforward, and certainly, I believe, more straightforward when you have a full understanding of the Kotlin language, and B, when you understand the goal and the paradigm at play for Android user interfaces, whether that is the view system or this new paradigm that we're utilizing, or this new toolkit that we're utilizing. So once you have that knowledge, you can leverage it to build out interesting and quite frankly attractive in many cases user interfaces.